Alright, today is 6.5a, and what we're going to be talking about is more two-step equations. We did some simpler versions of those two-step equations, and I gave you the basics of how to solve those basic two-step equations. However, we're going to be facing a little bit more difficult two-step equations today. The key concept stays pretty much the same, is that two-step equations have two different operations that need to be undone in order to solve. Essentially, to undo two-step equation problems, you want to work in reverse PEMDAS order. Okay, that doesn't change from yesterday. Remember, we said we want to get rid of the add and subtract first, then get rid of the multiply and divide. Okay, so that hasn't changed, but what we're adding on is maybe there's some parentheses in the equation or something like that. Okay, so therefore, first we want to undo the addition or subtraction part of the problem. Second, undo the multiplication or division part of the problem. Third, undo any exponents in the problem, which we probably aren't going to work with any exponents in this one. And lastly, we want to undo the parentheses. Okay, and so that's the really key focus that I want you guys to understand, is that the parentheses, whatever's inside the parentheses, we want to do last. Okay, so let's go going on a few examples. Example 1 says to solve 2 times x plus 4 is equal to 18, and then check our solution. So remember, we want to work in reverse PEMDAS order, and reverse PEMDAS order says to do the add and subtract first. Okay, there is an addition sign inside the parentheses here, but those are inside the parentheses. We do not want to touch what is inside the parentheses first. Okay, so there is no adding or subtracting outside of the parentheses, so we can't do that. Then it says to go on to multiplying and dividing. And as you can see, we have 2 times the x plus 4 inside the parentheses. So we need to get rid of this 2 first. And how we do that is we have to divide by 2 on both sides. Because when we do that, when we divide by 2, these 2's are going to cancel out, and we're just going to be left with the x plus 4 on the left side. And what you'll notice here is because it's only x plus 4 on this side, we drop the parentheses. We don't need the parentheses anymore because that's the only thing on this side of the equation. There's no need to distinguish that these are the last things to do. So now we have x plus 4 equals 9, and this is something that you guys are used to now. We just have to subtract 4 from both sides because 4 is being added to x. When we do that, 4 minus 4 is 0. We're just left with x on one side, and 9 minus 4 is 5. Therefore, x equals 5. Okay, now before we move on, we got to do that key thing. We got to go check our solution. We've got to say 2 times, we're plugging in 5 for x, 5 plus 4 equals 18. First, what we have to do when we're solving an equation is we have to do what is inside the parentheses first. So 2 times 9, 5 plus 4 is 9, equals 18. And we see 2 times 9 is 18. And 18 is equal to 18, so that checks out. We're good. We're good. Okay, let's do example 2. Example 2 says to solve 4 times 5 plus b is equal to negative 12. So remember, the first thing that we need to do is we have to work in reverse PEMDAS order. There's nothing being added or subtracted outside of the parentheses. Nothing being added or subtracted outside of the parentheses. So we have to divide next by 4 because 4 is multiplying against 5 plus b. And if we divide by 4 on both sides of the equation here, we end up getting 4 divided by 4 is 1, so we're left with just 5 plus b. Again, I can drop those parentheses. And negative 12 divided by positive 4, is a negative 3. Negative 3 times 4 is negative 12. All right, so at this point now, we have to get rid of this 5 that's being added to b. So we'll subtract by 5 on both sides. I think you guys know how to do that by now. And we're left with b equals negative 3 minus 5. Remember our elevator here? If we're on the elevator, we're at the at 0. And we still go down to negative 3. We're going down and then down 5 more because it's negative 5. And that's going to be a negative 8. b equals negative 8. All right. Now let's check our work because we always check our solutions here. Might move the paper over just a little bit. So we have 4 times 5 plus a negative 8 equals a negative 12. We want to make sure that this all works out here. 5 plus a negative 8, remember that is a negative 3 because the negative number is the absolute value of that number is larger than the absolute value of 5. So 4 times a negative 3 equals negative 12. And we already did this, didn't we? 4 times a negative 3 is a negative 12. That equals negative 12. That checks out. That is a true statement. Okay, so we've made everything equal. We know that solution is right. The equation is balanced. Therefore, we are right. Cool. Thanks, guys.